What are the types of biases that can occur during sampling? Types of biases: selection bias, under-coverage bias, survivorship bias. Selection bias. This bias occurs when the selection process for the sample does not properly represent the population. It may happen due to non-random sampling methods or when certain individuals or groups are systematically excluded or underrepresented. Non-response bias. The non-response bias occurs when individuals selected for the sample do not participate or respond to survey or study. This can introduce bias if the non-respondents have different characteristics or opinions compared to those who do respond. Third, sampling frame bias. Sampling frame bias refer to bias that arise from inaccuracies or incompleteness in the sampling frame, which is the list or source from which sample is selected. If the sampling frame does not adequately represent the target population, the sample may not be representative. Number 4, response bias. Response bias occurs when participants provide inaccurate or biased responses. It can result from factors such as social desirability bias, interviewer effect, or leading survey questions leading to distorted or misleading data. Volunteer bias occurs when individuals self-select to participate in a study. This can introduce bias because those who volunteer may have different characteristics or observations compared to broader population. 6. Measurement bias. Measurement bias refer to biases that arise from errors or inaccuracies in measurement instrument or procedures used to collect data. It can result from issues such as poorly designed survey questions, ambiguous response categories, or biased measurement technique. 7. Survivorship bias. Survivorship bias occurs when the sample excludes only those individuals or units that have survived or remained present until the time of sampling, excluding those that have dropped out or no longer exist. This can lead to an incomplete or distorted view of the population. It is important to be aware of these biases and take appropriate measurement to minimize or account for them during sampling process. Various sampling technique, randomization, careful survey design, and statistical adjustments can help mitigate the impact on biases and improve the validity of the findings. What is survivorship bias? It is the logical error of focusing aspects that support surviving some process and casually overlooking those that did not work because of their lack of prominence. This can lead to wrong conclusions in numerous different ways. For example, during a recession, you look just at survived businesses, noting that they are performing poorly. However, they perform better than the rest, which is failed, thus being removed from the time series. Survivorship bias is a type of bias that occurs when we focus only on individuals or things that survived or succeeded while ignoring those that did not. It is common error in reasoning that lead to inaccurate conclusion and misleading analysis. Survivorship bias often arises when we base our conclusions solely on observation or data that are available to us without considering the larger set of data that may be missing or inaccessible. This bias can be particularly problematic when studying success stories, historical events, or investment performance. For example, consider a study that analyzes the characteristics of successful entrepreneurs. If the study only includes entrepreneurs who have achieved remarkable success, it may overlook the vast number of entrepreneurs who failed or faced significant challenges. As a result, the study may draw conclusions or identify patterns that are specific to the survivors but not representative of the broader population of entrepreneurs. In investment context, survivorship bias can occur when analyzing the performance of investment funds. If only the funds that have performed well in the past are considered while ignoring those who failed or were liquidated, the analysis may create a false perception of the overall performance of fund industry. To mitigate survivorship bias, it is important to consider the complete dataset, including both success and failures, and not just a visible or surviving example. By accounting for the full range of outcomes, we can gain a more accurate understanding of underlying patterns, risks, and factors that can contribute to success or failure. What is selection bias? What is under coverage bias? Selection bias refers to systematic error in the process of selecting individual or units of sample, resulting in a not representative sample that does not accurately reflect the target population. It can arise due to various factors such as non-random sampling method, self-selection by participant, issue in sampling frame. For example, if survey is conducted by only interviewing individuals who are easily accessible, readily available, it may exclude certain segment of population and introduce selection bias. Similarly, if the participants are self-selected volunteers, this characteristic may differ from the broader population, leading to biased result. Under coverage bias, also known as coverage bias or sampling frame bias, is a specific type of selection bias that occurs when the sampling frame used to select the sample does not accurately represent the target population. It happens when the certain individuals or groups are systematically excluded or inadequately represented in the sampling frame, leading to undercoverage of their population. Undercoverage bias can occur due to various reasons such as outdated or incomplete sampling frames, exclusion or hard to reach or marginalized population, or limitations in the data sources used to construct the sampling frame. It can result in estimate and inferences that are biased and do not generalize. Both selection bias and coverage bias can significantly impact the validity and generalizability of research finding. It is important to address these biases by using appropriate sampling techniques, ensuring randomization, improving the sampling frame, and considering statistical adjustment to mitigate the biases and improve the representativeness of the sample. Explain how a ROC curve works. ROC, receiver operating characteristic curve, is a graphical representation that the performance of binary classification model at different classification thresholds. It provides a comprehensive evaluation of trade-off between the true positive rate, that is sensitivity, and the false positive rate, that is specificity across various threshold values. Here is how ROC curve works. Number 1. Start with a binary classification model. A ROC curve is typically used to assess the performance of models that classify data into two categories, often referred to as positive and negative classes. This could be a logistic regression model, a decision tree, a support vector machine, or any other binary classifier, where the classification method assigns a probability or a score to each instance, indicating the likelihood of it belonging to positive class. By adjusting the classification threshold, you can control the trade-off between true positive rate and false positive rate. As the threshold changes, the model's sensitivity and specificity will vary. For each threshold value, calculate the true positive rate and false positive rate based on the model's predictions and true levels of the data. True positive rate is the portion of actual positive instances correctly classified as positive, while FPR is a proportion of actual negative instances incorrectly classified as positive. Plot this FPR pairs on a graph of form of ROC curve. Assess the model's performance. The ROC curve provides a visual representation of model's performance across various thresholds. The closer the curve is to top left corner of plot, the better the model's performance, indicating a higher true positive rate and lower false positive rate. The area under the ROC curve, AUC ROC, is often used as summary measure of model's performance, where the higher ROC indicates better discrimination ability. Number 5. Determine the optimal threshold. Depending on the specific problem and the associated costs of false positive and false negative, you can Choose an optimal threshold on the ROC curve that balances the trade-off between sensitivity and specificity. This threshold selection is based on the specific requirement or priorities of the problem at hand. In summary, a ROC curve summarizes the performance of a binary classification model by plotting the true positive rate against the false positive rate at different classification thresholds. It provides insights into the model's ability to discriminate between the positive and negative classes and help in determining an appropriate threshold for making classification decisions. What is TF-IDF vectorization? Term frequency inverse document frequency. Vectorization is a technique only used in natural language processing, that is NLP, and information retrieval to represent text document as numerical feature vectors. It is a way to quantify the importance of each term in a document related to a collection of documents. Here is how TF-IDF, that is term frequency and inverse document frequency vectorization work. Number one, term frequency. It means frequency of a word, of a term or word within a document. TF is calculated as the number of times a term appears in the document divided by total number of terms in the document. The idea is that the more frequent a term is within a document, the more important it is for the document. Inverse document frequency. It measures the rarity of a term across the entire document collection. IDF is calculated as logarithm of total number of documents divided by number of documents that contain the term. The idea is that the rarer a term is across the collection, the more informative it is for distinguishing document. IDF calculation. TF-IDF is computed by multiplying the TF value of a term by IDF value of a term across document collection. This results in a numerical value that represents importance of a term in document related to the collection. Vectorization. Each document in the collection is transformed into a numerical vector representation based on TF-IDF value of term. The length of vector is equal to the total number of unique terms in collection, and each element of vector represents TF-IDF value of a specific term in the document. TF-IDF vectorization is useful in various NLP tasks such as text classification, information retrieval, document clustering, and search engine ranking. By representing text documents as numerical vectors, it allows machine learning algorithm to process and analyze textual data effectively. The resulting TF-IDF vectors capture the importance of a term in document related to entire collection, enabling comparisons and computations based on textual context. Why we generally use softmax or sigmoid non-linearity function post-operation in a network? Why a RELU in an inner layer? The choice of activation function in neural network depends on specific requirements and characteristics of tasks and hand. Generally, the softmax or sigmoid activation functions are commonly used as last operation in network for classification tasks, such as while RELU, that is a rectified linear unit, activation functions are often used in inner layers. Here is why. Softmax sigmoid in the last layer. Softmax function is commonly used in the last layer for multi-class classification problems. It converts the output of the network into a probability distribution over multiple classes, ensuring that the predicted probabilities sum up to 1. This makes softmax suitable for the task where the goal is to assign a single label to each input. Example, sigmoid function. Sigmoid is used in binary classification problems where there are only two possible classes. It maps the output to a value between 0 and 1, representing the probability belonging to one of the classes. The softmax and sigmoid functions provide a probabilistic interpretation of the network's output, making them well suited for classification tasks where the goal is to estimate class probabilities. They ensure that the network's outputs are constrained within a valid range and facilitate interpretation of the model's prediction. RELU in inner layers. RELU, that is, a RELU is a popular activation function used in inner layers of deep neural network. It computes the output as a maximum 0 and the input value. In other words, it sets negative value to 0 while leaving positive value unchanged. RELU activation functions are preferred in inner layers due to several reasons. Sparsity. Number one is sparsity. RELU introduces sparsity by setting negative value to 0, which can help the network to learn more meaningful and sparse representations. This can be beneficial for capturing important features and reducing the impact of irrelevant or noisy signals. Efficient computation. RELU is a computationally efficient to evaluate as it involves simple element-wise operations without expensive exponentiation or normalization. Mitigating vanishing gradient. RELU helps mitigate the vanishing gradient, which is common issue in deep neural network. The derivatives of RELU is either 0 or 1, providing a gradient signal that avoids a diminishing or exploding gradient during backpropagation. Using RELU in inner layers, neural network can benefit from improved learning capacity, computational efficiency, and mitigation of gradient-related issues, ultimately enhancing the network's ability to capture complex relationships in the data. It is important to note that choice of activation functions can vary depending on the specific network architecture, task requirements, and data characteristics. Different activation functions may be more suitable for a specific scenario, and experimentation with different options is often performed to find the optimal combination for a given problem. Thank you.